Welcome to Differential Equations, Chapter 3, Section 1, Homogeneous Equations with Constant Coefficients. In this section, we'll be dealing with problems with the general form ay double prime plus by prime plus cy is equal to 0. We notice homogeneous because of the 0 on the right-hand side. If there was some function or a constant, it would not be homogeneous. So in order to solve these, we're actually going to plug in some variable for y and take it to the power of the order. So we have y to the second order here, y to the first order. We'll take some variable to that. Some textbooks like to use other variables than lambda, but lambda is going to be the one that I'm going to be using today. So in this case, we'll have a times lambda squared, and we'll have b times lambda, because it's just to the first order, plus c because it's to the 0th order, no derivatives. And we'll leave the 0 on the opposite side. And then we can solve for lambda, and we'll actually put it in the form of e to the lambda t. And usually you'll have more than one lambda value, so you'll have e to the lambda t plus e to the lambda 2t. And this will be equal to your y function that will solve this differential equation. So let's go ahead and do an example here. So we'll have y double prime plus 5y prime plus 6y is equal to 0. Sorry about that 5. So how do we solve this? Well, we can plug in lambda. So we'll have lambda squared plus 5 lambda plus 6 is equal to 0. Through factoring, we can say lambda plus 3 times lambda plus 2 is equal to 0. So now we know lambda is equal to -2 and -3. So we'll go back to this solution, and we'll say y is equal to e to the -2t, because lambda is -2, plus e to the -3t. But remember, when we're integrating, we have to have integration constants. So we're going to add c1 and c2. So if we were given some values, which is actually the next problem in the Boyce DiPrima textbook, so we have y of 0 is equal to 2, and y prime of 0 is equal to 3. So now we can actually find these two constants. So when t is 0, y is 2, so we can say 2 is equal to c1 plus c2, and then we can say the derivative of this, which is actually, we'll do this off to the side here, is equal to -2 c1 e to the -2t minus 3 c2 e to the -3t. So then when we plug in 0 for this and 3, we get 3 is equal to -2 c1 minus 3 c2. So we can actually just solve for this system of equations here, and we'll actually multiply these all by 2, so we'll switch that to 4. We'll multiply everything by 2, so those are 2's. We can take out the c1's through addition. That means we have 7 is equal to 2c2 minus 3c2, which is -c2. c2 is equal to -7. We can go back to this one. We'll just plug in -7 for that. So we get 3 is equal to -2c1. Oops, move that up just a bit. 3 is equal to -2c1 plus 21. So we can move the 3 over here, so we'll get 18 is equal to 2c1, and we'll have c1 is equal to 9. That means we can actually plug these back in and get our specific solution. So we would have y is equal to, and c1, so it would be 9e to the -2t minus 7e to the -3t. And we can say that solution satisfies the differential we were given with these initial values. let's go ahead and do another problem here. So in this one we have 4y double prime, minus 8y prime plus 3y is equal to 0. We're given y of 0 is equal to 2 and y prime of 0 is equal to 1/2. So using the same process, we can say 4 lambda minus 8 lambda, forgot the squared, sorry about that. 4 lambda squared minus 8 lambda plus 3 is equal to 0. So we can actually use the quadratic formula for this. Just remember, we'll use lambda negative b plus or minus b squared minus 4ac all over 2a. So we can say that lambda is equal to negative b, which is 8, plus or minus the square root of b squared, which is going to be 64, minus 4 times a, so 16 times c, 16 times 3, let's just do that in the margin quick, which that's going to be 18, and then 48, and 64, well, we'll do that later, all over 2a, which a is that, so we have 8, which means we're going to have lambda is equal to 1 plus or minus, and 64 minus 48, we'll go ahead and do that off in the margin as well. Is 16. Remember, the square root makes it 4, and 4 divided by 8 is 1/2. So this means lambda is either equal to 1/2 or 3/2. So we'll go ahead and go back to this equation here, and we can say y is equal to c1e, and then the first lambda, so 1/2 t, which is t over 2, and then we'll add that to c2e to the next lambda, which is 3t over 2. Now we can use these initial values to solve for the constants. So we can say when t is 0, y is 2. So we can say 2 is equal to c1 plus c2. Now let's take the derivative of this. So we have y prime is equal to 1/2 c1 e to the t over 2 plus 3 over 2 c2 e to the 3t over 2. And remember, we're plugging in t as 0 and then y is equal to 1/2. So we have 1/2 is equal to 1/2 c1 plus 3/2 c2. So we'll actually move this one down. So we have 2 is equal to c1 plus c2. Okay, so let's solve for it. We can actually multiply all these by 2. So we'll keep the bottom one the same. 1 is equal to c1 plus 3c2, and then we'll subtract these. That means we'll get negative 1, the c1s will cancel, and 3 minus 1 is just 2c2. This means c2 is equal to negative 1/2. Now we can plug the c2 back in here. So we'll have 1 is equal to c1 minus 3/2. This means c1 is equal to 1 plus 3 over 2, which is going to be 5 over 2. So we'll actually, I'll write that again just because you can't see it. What we had before was y equals c1 e to the t over 2 plus c2 e to the 3t over 2. And we already know our two constants, so we know that the final solution will be negative, can't switch them, 5/2 e to the t over 2 minus 1/2 e to the 3t over 2.